Okay, so today what we will do, we will start our dynamic programming part, and daily what we will do for next 4 days, we will solve one problem from the advanced graph. So first we will pick this problem from the advanced graphs, which is minimum cost to connect all points. Okay, we need a short link for this. Let's see. Monday module. Okay, so the question says you are given an array points representing integer coordinates of the some points in 2D plane. Okay, so we have some points in the 2D plane where point I. Okay, we have a point. We have points in 2D plane. The cost of connecting uh, 2 points is Manhattan distance. So Manhattan distance is defined by this particular formula. Return the minimum cost to make all points connected. All the points are connected if exactly one simple path between any 2 points. Okay. So what the problem is saying? So we have some points on the plane. So here we have one, two, three, four, 5 points, which is this, and this. So we have these 5 points, and what we need to do, we need to connect these points. So here we have connected these points like this, and cost of connecting these points is the difference between the Manhattan distance between these points. So we can connect the points as shown above to get the minimum cost of 20. Okay, so we notice that there are unique path between every pair of point. Okay, so basically this is nothing, so we need to find the minimum spanning tree here. So for that we have algorithm called prisms algorithm, which I have pasted the link in the description. So I think previously, let's try to solve this now. So what we can do, how we can solve, so we will consider these points as the nodes in the graph, and we consider that all of these nodes are connected to each other, and we need to find the edges between them, means the edges which we can choose. There can be edge from this point to every other point, but we will connect this point to only one point. Okay, so we will assume that there is a edge between every pair of points. So we will first calculate that these edges. Okay, what are the constraints? So all the points are distinct, and we have 1,000 point at max. Okay, so we have these points, and what we need edges between uh, for this particular node. We need this edge, means the edge connecting this node to and all the other nodes. Okay, so Okay, what we will consider? We will consider we will assign a number to each node. Means the index of that node will be uh, that node's number. So basically, these are nodes, and for this node we will assign 0, and for this 1, for this 2, for this 3, and for this 4. And for this zeroth node we will find every edge from connecting this node with other nodes. Similarly, we will find all the edge connecting this node with other nodes and this node with other node. We will create a undirected graph, and then so what will be approach? Create a undirected graph using points. Considering each point as a node. And then we can find the MST, minimum spanning tree. So this will be our approach. So we will also see how we can implement MST. So let's first create the graph. So how we can create the graph? We can make a map from integer, and which can contain list. So this list will store the edge and weight, means the two node and the weight. Okay, so this will be a graph, and we will iterate our points. So let's define length for the points. Points dot length. Okay, and we can iterate our points. For every point we can iterate that other point also, means all the remaining edges. So that will be I plus 1, and I and j smaller than n. So what we need to do now, from between ith point, suppose from this point and then this point, jth point, we need to create a edge. Means for every point we will create a edge to all other nodes. For this particular zeroth index node, we will create a edge with remaining these four. For this, we will form the edge with these all fours, and that should be a undirected. So how undirected graph? So how we can do? So currently we will first create the distance. Means we need weight. So the weight will be Manhattan distance. So what is Manhattan distance? It is given by xi minus xj absolute value plus yi minus yj absolute value. So weight will be math dot absolute. So our xi will be this I at point 0 position, and our xj will be mm, this j at points 0, and our yi will be points of I1, and yj will be points of j1. So these are our xi and yi, and this is our Manhattan distance. Okay, so this is the weight between, this is the edge weight. So we will put a, what we will do in our graph, we will put a edge between I and j and I, because we need to create a undirected graph. So we will put edge between I to j and j to I. So compute if absent new array list dot add j, and in j we can add k, sorry, I. So we have created a graph. So this is a graph connecting a point to all other points in the points matrix, points array. So we have done with the first step. So this is our first step. We have created our first step. Now what we need to do, we need to find in this graph, what we need to find, we need to find minimum spanning tree. Means we need to connect all these points. So these, all these points are forming a tree. Okay. Now we need to find the MST, means minimum spanning tree. So how minimums? So we will select a random node from which we will start. So let's say we will start from the ith node, and from that ith node, what we will do, we will look for the so in our graph we will be having from this particular node path to this node, this node, this node, and this node. So greedily we will be choosing the, means we will be creating a priority queue, and we will be storing the distance in the priority queue, and we will be greedily choosing the minimum distance, means the next minimum edge. Okay, so means we need a priority queue. Let's say we call it as a priority queue of a pair. So what we can do in our pair, let's first define our pair. Public class, we need a v edge and a distance, means pair will store the node to which this edge is going, and the distance of this edge. So we will initialize these both variables as 0 initially, v as the -1 and distance as the 0. Or when we are passed these values in creating the pair object, we will assign that values. Okay, so now in this priority queue, we can start from any node. We will choose the 0th point. We will choose the 0th point. So what we will do, to our priority queue, we will create a new pair, and this pair will go to 0, and its distance will be 0. So initially we have a edge going to 0, and which will have a distance 0. So until our priority queue is not empty, what we will do, we will Now at the top of our priority queue, so we also need to define that how we will be storing in priority queue. Means in pair we have two parameters. We need to decide that on based on which parameter we will be storing values in parameter. So we need a comparator. So what comparator will do? Comparable. So comparator will uh, we will tell the priority queue that do sorting based on the distance. So there is a function in this comparator interface implements public int compare. So what we do, other, we will take a other pair and we will return our current pair's distance minus that other pair's distance. So now whenever we store something in the priority queue, that will be stored on the basis of this comparator, and comparator tells that store based on the distances, means keep the minimum distances on the top. So now we have a min priority queue based on the distance. So we will pop out the minimum distance from our priority queue. So pair node will be priority queue dot pop. So now we have popped out this pair. We have popped out this pair, this particular node. Also at the end, what we need to return? We need to return the minimum distance. So we can create an answer variable min distance and initialize it as this 0, and at the end we can return this min distance. So now what we will do, we will add this distance, minimum distance plus node dot distance. Now we have visited this particular node, we will move to its neighbors. And what we will do, we will iterate to its neighbors in our graph. So graph will give us a uh, detail of the neighbor data. Means at 0th index we will have the value of that neighbor's index in this points array and the distance to reach that neighbor. So graph dot get uh, we will get node dot v. Okay, and if this data doesn't present, we will return an empty array list. So this is our neighbor, means neighbor of the this node. And one by one we will put these neighbors uh, into our priority queue. Okay, so one thing also that what we are doing here is we are creating a tree. So suppose from this node we are going to this node, but we can as this graph is undirected, from this node we can also reiterate to this node. So we need to mark this node as the visited. Means what we can do, we can create a visited array. New boolean visited, new boolean n. Okay, in this, and then after popping out a node we can say that we have added its distance and we can mark it as visited. So visited of this node dot v as the true. And also while iterating neighbors, we can avoid neighbors which are visited. So we will only take if our this particular neighbor, so our neighbor will be neighbor data 0 and it neighbor distance will be neighbor data 1. So if it's not visited, if our neighbor is not visited, then in that case what we can do, we can add it to the priority queue. We can add a pair to priority queue that we have this neighbor and this neighbor has this distance. Whatever we add to priority queue, but when we is come to polling, we will only pop the minimum distance. So that's how we are moving greedily, means we are only we are adding edges, but we are only picking the edges which are smaller. So I think this is the implementation of prism algorithm. Let's run. What error we are getting? Income int cannot you can okay, we need to add a array here, means we need to add its weight also. So what we can do, we can add new int array j and its weight. Okay, similarly we can add a array here I and its weight w. Okay, do we have any other array? Okay, we have an array in pair class also. Let's see separately what this error is saying. Pair is not does not overrest compare to. Okay, we need to implement this function compare to, I think. Okay, we are getting wrong output. Graph from 0 to y plus 1 j equals to I plus 1, j smaller than xi, xj. Distance, this will be weight, compute if absent, adding this j to w, this I to w, map is correct. We have chosen a min distance array, min distance int, priority queue, storing on the basis of minimum distance. Popping out the current node, adding current distance to node, marking this node as visited. Now for this node, we are iterating its neighbor, taking current neighbor as this, neighbor's distance as this. If this neighbor is not visited, we will add this neighbor and its distance. Hmm, let's see test case. This test case 312 minus 2 5. Do we have diagram for this? A point at 312 0 1 2. Let's see what edges we have. 4 map high, 4 map country. Output entry set. En dot get key. Okay, so for this particular test case, this one. This is zeroth node. So from this is zeroth node, this is 1th node, and this is the third second node. So from this zero node, I have a node from this node to this node, 0 to 1 node having distance 12. Okay, how its distance is 12 means 3 minus 2 will be 5, and 12 minus 5 will be 7. 7 plus 5, 12. Okay, 12 distance from this node, from 0th node to second node, the distance is 3 minus 4, 7 plus 11, 18. Okay, from 1 to 0, I have this node. From 1 to 2, I have this node having distance plus 2 and 4, 6. Okay, 18, 16. Okay, so our graph is correct. Okay, let's draw graph here. Okay, so what we are doing, we are initially taking minimum distance as 0 and creating a priority queue, and in a visited array, and in priority queue we are adding initially our 0th node with 0 distance, and we are popping out this pair and adding 0 to our minimum distance and marking this node as the visited. Now from this node we are iterating its neighbors, so we have two parameter v and distance in the pair. This distance. Okay, so we have marked this as true. We will now iterate its neighbors 112 to 18. This will be 1, this will be 12. Okay, this pair, and we will check if it 1 is not visited. So initially our visited array will have 0 only. We have marked 0 true here. Then we will put 12 into our priority queue. Means we will put this neighbor 1 and 12, this edge into our priority queue, 1 and 12. Okay, so from 1 we go to 12. This will be like 1. 0 to 1 is distance is 12, and 1 to 2 distance is 6. So our answer should be 18, but we are getting 36, I think. Okay, so now next step what we will do, we have added this pair in priority queue, so now we will pop this pair 1 and 12. Okay, so what we will do, we will add this distance 12. So now our distance is initially it was 0, now it is have become 12, and we will iterate once neighbor. So its neighbors are 0, so we will iterate, and first neighbor will be 0, so it is visited, we will not add it to the priority queue. Then we will iterate its neighbor 2. So 2 is not visited, so we will add 2 and 6 to our priority queue. We have popped this out and added 2 and 6. So now we will pop out this 2 and 6, and we will add 6 to our distance. So distance will become 18. And now we will iterate over 2's neighbors. So all the neighbors of the 2 are visited. Then maybe we are not creating correct priority queue. Maybe this will give us max priority queue based on the distance we need to store. We can see what we are popping out from the priority queue. Means we can print our node which we are printing, which we are popping out from the priority queue. Okay, we are popping out 0, then 1, then 2, then we are again popping out 2. Okay, we also need to add a check here also, that we don't pop out the element which is already visited. It can be in priority queue, but we should not visit it. Okay, if it's visited, we can continue. Priority is not empty. Okay, we will have means both neighbors 1 and 12 and 2 and 18. After we do this thing, 0 will visited. I did these two, putting out 1. Mm, After popping out this 1, mark this one as the visited. Or we can see what our criteria contains at this point. Means we are first going to this. We should not go to this 2 again. We did 1 and 2, 0 and 12, 12 and 18. Then we are getting 1. Means mark this one as the visited. This after continuing, what issue we are having? We are have now iterating 0, 1 and 2 only. Okay, okay. But we have added to the distance. We don't need to add it to our distance. Means if the node is already visited, we will not visit it. Otherwise, we will add distance. But what we need here, we will need this. Need to pop it here. Then we can add the distance and mark it as visited. Okay, so this was, I think this is called a prism algorithm. And there's one more algorithm to find MST, which is Kruskal algo. So I think we can implement that also. That uses a disjoint set. Let's see if this works. Or it- Okay. Okay. So what we will be doing is we will be solving these three problems one by one. Means on each day. But today we will be starting with the dynamic programming. So we can start with the medium ones, or we can solve the easy ones also. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one step or two steps. One step or two steps. Okay. We have got we have to take total step as n. And what we can do, each time we can take one step or two step. Okay. So like we need to this steps. So initially suppose we have zero steps. What we can do, we can either go to stair number one, or from this zeroth step we can go to the two steps ahead. Okay. In how many distinct ways we can climb the top? Okay. Okay, so if we want to climb the two steps, what we can do, we can take the one step initially, and then we will be left with only one step, so we cannot take two steps, so we have to take the one step. So one way is this, is from 0 to 1, 1 to 2, and second way is we can directly go from 0 to 2. So we have two ways. Okay. In in second case, we have three steps. So what we can do, we can go from, we can take all the one steps from 1 to 2, 2 to 3. Or what we can do, we can take one step, means first we can go to the first stair, then we can take two steps and directly go to the third stair. Or we can first take two steps, go to second stair, and then can take one step and go to the third stair. So these are the three ways. Okay. Okay, we have n. So from n, we from last stair we can also go to 0. Means first we need to climb n stairs. Then suppose we climb one stair and we can go to the n minus 1th stair. And also we can go to the n minus 2th stair. And the ways in which we can go to these stairs, we need to add the total ways. And how we can say that we have reached a way, when our n becomes 0, then we can say we have found a way. We can return 1, that this is a valid way. I, isn't it Fibonacci series? Like for this this case, third case, where n is 3, what we can do, we can call our function for n equal to 3, we can call our function for 3 minus 1, that we can go to the second stair and we can go to the one stair. Means from 3 we can go to second stair, and from 3 we can go to this one stair and this stair. Okay. And from this second stair, then we will have two more ways. Okay, so I think this can work. Okay, while subtracting 2, we can means have a negative value also. Means if we have n as a 1 here, we can subtract this case also, but this will be 1 minus 2 will be minus 1. So we need to handle the minus cases also. So if our n becomes minus 1, or if it becomes a negative value, let's say, we can return 0, that this is not a possible way. Okay, but I think we are using recursion, so we are using on every level we are calling our function two times, so it will have exponential time complexity. Means 2 raised to the power, and n will be number of calls we are making. So we can make n calls in the case we make this call, so this will be its time complexity. So we need to memorize it. Means we need to store the answer for the repetitive subtrees. Means for the problems which we have already solved. Like we can create a DP. We have 45 max size here. So on safe side we can create it for 46. Means if our n is 45, we need to store the value at 45th index. And suppose we store values in our DP and we check if that value is present in DP. Means if this DP is not equal to 0, because it will be initialized as the 0. So if it is not 0, we can return the value which we have stored. Otherwise we can store the value in our DP. Hmm, okay, so this is the classical problem of Fibonacci series, I think. Dynamic programming memorization math. Okay, I can't paste this solution, this particular description here. So this is, I think, good description, which I have explained. Okay, so we can move to next question. I can paste link if you want to try this question. Okay, we have MST. Okay, let's see next question. Minimum cost climbing stairs. So the question says you are given an integer array cost where cost I is the cost of the ith step on a staircase. Okay. So basically we have this cost array. This is the cost to step on the zeroth staircase. This is the cost to step on first staircase. Once you pay the cost, you can either climb one or two steps. Okay. So we have option like, okay, we can climb either one or, okay, you can start either from zero index or with one index. Return the minimum cost to reach the top floor. Okay. So what the question is saying, let's say we have this particular array. So the question is saying these are the staircases. Means initially this is the ground level, and then these are the staircases. That this is the first staircase. This is second, so on, and this is the top floor. So what we need to do is we can either start from this staircase or this staircase. Means staircase at zeroth index or 1th index. Suppose we start from this staircase, and this is the cost that we need to pay 1 rupee to step on this staircase. So suppose we pay 1 rupee. Now when we are on this staircase, we can decide uh, whether we need to take one step ahead or whether we need to take two steps ahead. So here we can see that taking two steps will be beneficial, that uh, because the second stepping on this staircase is causing us to pay 100 rupees. So clearly this is a better way. So this is how we need to decide uh, whether we have to take one step or two steps ahead. And the way to identify these DP problems is that we can look for these words, that minimum or maximum. So most of the DP problems will contain either minimum, to find the minimum, or maximum. Means this can give a hint. One step or two step. Okay. So we can start from 0 or 1. So what if we consider our ground as the -1? So if we take one steps, which will be +1 to the index, so we will reach this zeroth index. And what if we add 2? We can reach this particular staircase. So what we can do, suppose we call a function find minimum cost, and initially we start from the -1. This will we will passing the staircase which we are on. We will pass considering ground as the -1. So we are starting from ground. We can pass over this cost array. Okay, and at last this function will return us the minimum cost. So let's implement this function. So public int find minimum cost int staircase int cost. So if our staircase, so this is the base condition. So suppose if our staircase is greater than this index, means if our staircase number is this, so this means we are already at the top. So if our staircase is greater than this array's length, means this array's length or equal to this array's length, then we can say that we have reached the top. We are already at the top, so we can return 0, that no cost is required, we are already at the top. Now we have two options. First option is taking one step from here, and second option is taking two steps from here. So suppose first we take the first we choose a way that we want to take a one step. So this is the option one, means we are taking one step. So we will call this function, and as we are taking one step, so we can take this staircase and we can plus one to our function that we are taking a single step, so, and we can pass our cost array. So okay, so now as we have taken one step, so also we need to add the cost, that this much cost is required, means if we are on this particular staircase, we will require this much of the cost to pay. Okay, and the second option will be, we can copy it, this function call, and we can, this will be our second option. And now we are taking two steps, so we can add the cost of the second array and second staircase, and we can add 2 also here. So now we have chosen these two options, that one where we have chosen is taking one step, and second one is taking two steps. And what we need to do is we need to find the minimum cost. So at the end we can return the minimum cost of the option 1 and option 2, and rest of the thing recursion will do for us. So I think this is the recursive implementation. So we need to implement the memoization also, means we need to find that, okay, so we are getting array out of bound, 3 out of bound for 3. Okay, okay, okay. Okay, suppose we are already here and we are moving to the, okay, suppose we are already here and we are moving to the next step. So we don't need to add the cost of the next step, we need to add the cost of the current step. Okay, cost of the staircase, if we are at n minus 1th index greater than equal to cost dot length, currently we are at minus 1. Okay, for this part, for minus 1 we don't have any staircase. So what we can do in the case of minus 1, we can simply put 0 here, means we can put a condition like we calculate this cost. Okay, so the cost will be if our staircase is -1, means we are on the ground, so we don't have to pay any cost if we are on the ground. If it's -1, then we have to pay zero cost, otherwise we will have to pay this cost. So this is our cost, and we can add this cost here. I think now we will not get out of bound. Okay, we are still getting out of bound. If it's -1, no, we are not getting out of bound. We are getting something else. Is already defined. Okay, cost is already defined. Current cost, we can call it current cost. Okay. Mm, So now we need to memorize this solution because this is a recursive implementation. This is not a DP, means this will become only DP when once we memorize it. This is a just a brute force recursive solution uh, which has the exponential time complexity. So we can have in these recursive calls some repetitive computations. So by using DP we can avoid that repetitive computing. So what we need to do is, so we need to implement DP. So we will implement, means whenever we need to implement DP, we will implement only for the variables which are changing, means value of the variables are changing. So in this particular function, the value of only staircase is changing, means we only have one variable whose value is changing, means we are increasing its value, or means we are increasing its value, so its value is basically changing. So we need to implement DP on this particular part. So our staircase number can go from let's, so if one variable is changing, so we need one DDP. If two are changing, we need two DDP. So here we need one DDP, and the length of the staircase, means the number of the staircase we can have is the size of this array. Okay, so this is our, we have initialized DP. We can pass it into a function. Okay, and we can check if our, we have already computed for our current staircase, we have already computed the answer. So one we need, so we are passing staircase as -1, so this can, if passed as the -1, can give us error. So what we can do, we can uh, make sure that our staircase is not equal to -1, and our, and we have already calculated answer for this particular staircase, means it's not 0. So in that case we can return our the answer stored which we have stored in our DP. Okay, so we can return the answer from here. Otherwise, if we haven't calculated answer for current staircase, we will go recursively and look for the answer. And after finding the answer, after these calls, we can store that answer at the end in our DP. So basically, Our current answer will be this, and we can store this current answer into our DP. Staircase is equals to current answer, and at the end we can return current answer. Okay, we need to add a semicolon here. Okay, we need to pass DP also in these functions. Okay, again we are trying to store the answer at the -1 index, means for this case -1. So one thing we can do is, what we can do, we can, without handling explicitly this -1 case, we can increase size of our DP, and we can store the answer for the current staircase at the index staircase plus 1. So that will handle our -1 case, means in the case of -1 we will be looking for the 0th index. It will not give us this out of bound error. Okay, so we are getting clearly for the last case, because our array has all the zeros. So what we can do here is, means our DP is also initialized as 0, so we need to initialize it uh, onto something other value, because our cost can also be 0. So we can put minus ones in our array, in our DP, and we can compare with the -1. So -1 will make sure that answer is not computed for a particular case. So we can submit it. Okay, so this was the implementation. Okay, I'm forgetting previous thing. What are your revision suggestion? Mm, yeah, you should make your short notes for every topic, and you can go through that short notes also. You can paste some notes on your wall that you can look for them. And one way to not to forget is to, and since you have only doing it from a month, so it's obvious to forget things. So you need 4 or 5 months more to practice, then you will remember something. Okay, so these were the, I think, most doable easy problems. Means this should be these problems should be categorized as the medium problems. Okay, so this will be last problem we will be solving. Battery is on 2%. Okay, so the problem says you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is the adjacent house have a security system connected, and it will automatically contact the police if two adjacent houses were broken in onto the same night. Okay. Given an integer array nums representing the amount of money each house return the maximum amount of, so here we have the keyword maximum, so this clearly says it is a DP problem. So return the means don't go for the keywords, go for the intuition and the uh, problem statement. It's just a hint, not a solid proof, and not advised to look for these kind of keywords. So we need to find the amount of money we can rob tonight without altering the police. Okay. So the only constraint is that stopping you from robbing each of these, that the adjacent houses have security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. I have completed my year in 20, my BTech in 23. So currently I am working, and tomorrow morning I will be going to my office and waking up at 7:30 and going to office at 9. And tomorrow will be my last day as I have completed 2 days and I need to go to office 3 days. Okay. So we have means this is the first house, this is second house, this is third house, fourth, fifth. So first house has, say, 2 rupees, next house has 7 rupees, next has 9 rupees, and robber will start from from first house, and he cannot rob two houses, two adjacent houses. Means if robber robs money from first house, he cannot rob money from the house seventh house, because these are adjacent, and an alarm will call the police. So if he decides to rob the second house, then he should choose any house from these houses, but at least not this house because this is adjacent. So initially, when I have approached this problem, I have thought that he cannot rob the adjacent house. So what if I can go greedily and I can choose houses, I can skip one house and choose next house, skip one house and choose next house. Suppose if we decide some strategy like first we rob house at even position and compare that value with the houses at odd position. So at even position we will be having houses. So let's say this is zeroth index, so this is even. So 2, then leaving 7 we have 7, sorry 9, then leaving 3 we have 1. And as of odd houses we have 7 and 7 and 3. Okay, what if we compare these values 12 and 10? So we can go for even houses. So this is a completely wrong approach. This is not a greedy problem. And one example which can fail this is like we can in this house, suppose he starts from second house and then we have a house value 3, 4 and 10. So if I choose this and this will give me 6. This will give me 13. But if I have a 2 here and 4 here, so here I think this example will work. Suppose if we choose the even indexes, so the values, the money at the even indexes will be 4 and 4. So 0 and 2 index we are choosing. So 4 and 4. So total money will be 8. And if we choose odd houses, which will be 10 plus 2, the total money will be 12. So our algorithm, if we choose even and odd indexes, will return 12 as the answer. But the answer for this problem is, suppose the robber robs this house, then he can't just rob this house because this is adjacent. He can rob this house, which he robbed in even position. But he also suppose skips this house also and chooses this house. So this house and this house are not also adjacent. So if he chooses this and this, the total money he can rob is 14. Okay, so we can choose a house and we can skip any number of houses in between, and one we have to skip, that is for sure because that is adjacent, and other than that one we can skip any number of houses we want. So this is a DP problem. We will simply use this same kind of approach which we have used in the previous question. So uh, let's start. Okay, so we will find create a function, find maximum amount. Okay, so this will find the maximum amount the robber can rob. So initially we assume that we are at zeroth house and we will pass over this array nums. Okay, so this function will return us the maximum amount. So without thinking, we will return this function's output. Thus, this function will return us the maximum amount. So let's initialize this function. So this is index at which we are currently, and this is our houses having money. So if our this index is greater than the number of houses we have, so we can say he cannot rob anything. We can return 0. Okay. Now we have two options. Okay. Now we are at this house. Okay. We can rob this house. Okay, we can rob this house. Or we also cannot rob this house. Okay. So we have two options. If we are at a house, we have two options. We can rob it or we can skip it. Let's consider this as first. It will not make any difference, but for the sake of easiness, so we have two options. First one is we can skip, and second one is we can rob a house. So let's implement uh, the line if we skip it. So in skip will be, we will call our function, this function, and if we skip this house, can we take the next house? Yes, we can take, because it's adjacent house with we haven't decided to rob it, so we can rob its next house. So what we can do, we can pass index plus 1. This means this is the eligible index of the house which we can rob. Okay, and we can pass our nums. So we are skipping this house, so we are not getting any money from it. Basically we are getting 0 money from it. Now we have a second option, we can rob the house. So robbing means we are taking the value, means we are taking this value with this money from this house. So this means we are considering this money at index position. And if we rob this house, we cannot rob its adjacent house. That's the condition in the question says. So we need to move a two index ahead. So in this function, we need to move two index ahead. And at the end, we have two parts. First call is that we have skipped, and second call is we have robbed. And we need to return the maximum of both, the maximum amount of money we can rob. And we have to not worry about anything else. Recursion will do for us. We just have to solve it for a particular part, particular problem. Other recursion will do. Okay, so let's see if this works. Okay, so this is a exponential approach. We need to do it in what we say. Uh, we need to memorize it basically. This works in exponential time, so this will give us TLE for 30 or 40 length of the nums array. So we need to implement DP. So here in this function, only one variable is changing, which is index. Its value is going from 0 to the length of nums array. So we'll create our DP. Wait a second. We will create our DP array, which will be same as the size of the nums array. And we can initialize values in our DPs as -1. So this will fill my, so this is initialized by 0 values. I will we will overwrite it with the -1. So now all values in the DP will have -1 value. We will pass our DP into our function, and we can check if DP, if we have already calculated answer for this particular index. So if it's not -1, this means we have some value stored in it, means we have initialized it. We can return its value. Otherwise, we need to calculate. We can't return. So we have calculated here, and after calculation, we can store that value for the future calls. It will help future calls to get the value. Okay, so we can run this. Okay, we are not passing nums, sorry, DP here. And this is unnecessary. For the sake of explanation, we can submit it. And I only know DP by using recursion and memoization. I don't know DP how to implement it in uh, iterative way, in tabular way. But I can convert a solution into iterative way after some struggle and wasting some time, and I will not do that today. Okay, so tomorrow first we will pick up problem from here, maybe this, and then after this problem, if we able to solve this, we can solve problems from DP part. O- was it house robber 1? Okay. Okay, thank you guys.